Okay, let's do some kinematics. Have another Edexcel past paper exam question. So, we're given a small ball projected with speed u from point O top of a cliff, 25 meters above the ground, projected angle 45 degrees, and it's hitting the ground at point A 100 meters away. So the ball is kind of traveling in this path over here. Model of the particle, or that usual stuff. Using the model, find the value of u, or show the value of u, whatever. So, kinematics, you're always going to do a SUVAT, and you're going to do a separate one for the vertical and horizontal motion. The way I like to lay it out, I do my horizontal motion and my vertical motion. But when I do a SUVAT, you've got to take a step back and think, what period am I doing my SUVAT across? Like from where to where? In this case, I'm giving a lot of information about how far the ball is sort of away at A. Right? I know how far away A is horizontally and vertically. So it makes sense for my first bit, I'm going to consider SUVAT during the motion between O and A. You can't have your values of S, U, and V, and T until you know where you're doing your SUVAT from. Okay, so between O and A, let's fill it in. Let's start horizontal. So horizontally, between O and A, I've gone from O to A, I've travelled positive 100 meters because I'm going to go right is positive, so S is 100. For U, we're going to do our usual trick over here. So, this is U at the angle. It's an angle of 45 degrees, so we split that up into its two components. Horizontal velocity, horizontal component of U cos 45, vertically of U sin 45. So horizontally, initial velocity U cos 45, U is just an unknown number. V, very often you don't really care about V, unless it says, unless it asks you to find the value of V. Especially the horizontal velocity, we know it's actually just going to always be the same. I'm going to skip over this one for now. A is always 0, and T I'll skip for now as well because we're not told T. Vertically, from O to A, this is why that direction is really important. I'm actually going down 25 meters. So I'm going to take upwards to be my positive. So going down 25 will be negative 25 displacement. Initial velocity is upwards by U sin 45, so that'll be a positive U sin 45. Final velocity, don't put V equals 0, even though when it hits the ground it stops. Okay, this V would mean how fast is it moving right as it hits the ground or right before it hits the ground. You can't put 0 because after it hits the ground, it's a new system. The acceleration is different. There's been a force. You can't do the same through that. So this V not being 0, A being negative G, I can have that. And in this case, I haven't got a lot of information. You need 4. In a SUVAT, you need 3 knowns and 1 unknown. So what you can do, the value T is just time, how long it takes to go from O to A. Obviously, that should be the same, horizontally and vertically. So you can use the same T, the same variable, in your horizontal column and your vertical column. It's just how long it takes. You can't do that with any of the other letters. Sometimes I see, there's a S unknown horizontally and an S unknown vertically. And students will use S for both, and then when they're solving equations, they treat them as the same variable and collect them together or cancel them. But this would be a horizontal displacement. This would be vertically. They're totally different. It's only ever with time where you can use the same one. And that means it's a very, very common thing to see in these questions where you sort of make T the subject of your horizontal equation and substitute it in to your vertical equation. It's very common. We're actually going to see that right now. So horizontally, what do I have? Well, I don't have any V. I don't have V. So I'll do the S equals U T plus half AT squared. You might be more comfortable just doing the speed equals distance over time thing here because A is 0. But you can also just see it with A being 0, this term goes away. It's the same equation. So 100 equals, now initial velocity is U cos 45, and T is my unknown, T. So that's there. V, so vertically, again, I don't have any final velocity, so I'll do the same through that equation. S is negative 25, U is U sin 45, T is just T, the same T as before. A is negative G, so I get negative G over 2 T squared. And like I said, first of all, going back, reading the question, what do I actually want? it's wanting u. And I have two unknowns, one there, one here. Sorry, two equations and two unknowns, right? U and t are my two unknowns, so I should be able to solve and find u. So like I said, I'm going to eliminate t. That is the way to go in a lot of cases. So to eliminate t, let's write it to the subject. So t equals 100 over u cos 45. You could at this stage replace cos 45 with root 2 over 2 if you wanted to. And let's put that in. Let's put that in over here. So what do I get? Negative 25 equals u sine 45, and then t is 100 over u cos 45. Negative g over 2, and then that whole thing squared, so 100 over u cos 45. Good. Okay, in this case it was quite nice keeping it sine and cos until now, just because sine over cos I know makes tan. And tan 45 I know is 1. So tan 45 here, just 1, so it does nothing, so I just get 100 minus g over 2. 100 squared is 10,000 u squared, and cos 45 is root 2 over 2. If you square that, you get 1/2. Okay, I'm going to add my 25 over, add the g over 2 term over, so I get, let's do this properly, numerator 10,000 g, this term here, yeah. Denominator 2 times u squared times 1/2. The 2 and the half, they are both in the denominator. They're just going to multiply together like normal and cancel. Just get the u squared, and I've added my 25 over, so 125. And if you just solve for u here, I mean, you could just type it in. You do 10,000 g divided by 125 and square it the answer. You get 28 meters per second. Now, this could have been, plus or minus. If I look at my picture, well, u is my initial velocity here is a positive number, right? So I'm going to take the positive root. U equals 28 meters per second, which is what was asked. So I'm done there. Let's do part B. Part B says find the greatest height of the ball above the ground. So the greatest height, that's not an O, that's not an A. That's at this sort of extra point in the middle. I'm going to click B. So now I'm going to totally ignore all my previous working, all these variables, and do a new through that, this time from O to B, because I'm interested in how high up B is, or how much higher I've gained from B, and I'm only going to get that by doing a through that between O and B. Okay, so this time from O to B, and everything could be different. Again, H, B. Let's go through it all again. Horizontal displacement, O to B, don't know. Don't really care here, I'm not being asked that. Initial velocity U is still going to be the same. That's going to be U cos 45. Now I'm just going to write down here what that actually is, because now I have U. U is 28. So U cos 45. And in fact, U sine 45, they're both going to be the same, because cos 45 and sine 45, they're both root 2 over 2. Putting 28 in there, I'm going to get 14 root 2 for both of those. So I can put 14 root 2 here. V horizontally, don't know, don't care. I mean, I do know it's the same as U, right? Because A is 0. And T also unknown. Not a lot here, let's go vertically. Vertically, from O to B, well, the displacement S is kind of what I want, isn't it? That's going to be how much extra height I gain between O and B. So I'll put my question mark here, this is what I want. U, like I said here, is the U sine 45, which is still just 14 root 2. V, now V I actually do know. This is the one kind of situation where, unless they're asking for V, you still want to use it. Because at the very top, at the very peak, your vertical velocity is 0. Okay, it's turning, it's going from moving upwards to moving downwards. So just something to learn. Top of your path, vertical velocity is 0. So I put in V equals 0. A is negative G, always is. And T, well, I don't know T. And actually, if you look what I've got, I have enough. Just here. I've got 3 known values and 1 unknown value. And with a through that, that's all you need. So I have the through that equation with no T, just looking vertically. Horizontal didn't help me in this case. That's going to be v squared equals u squared plus 2as. 0 squared equals now 14 root 2 squared is 196 times 2, so 392 plus 2a, well, that's minus 2g, so I'm going to put minus 19.6, and then s is my unknown that I actually want to solve for. If you do 392 divided by 19.6, you can get s equals 20. Okay. I haven't answered the question yet, because the question does say finding greatest height above the ground. Right? Okay, so this additional height gained was 20 from O to B. Above the ground, there's still this 25. So my final answer is going to be 45 meters above the ground. So let's just put 45 meters, put a box in it, so examiner knows that's my final answer. Part C. So we have a refinement to the model. Right, we're going to include air resistance. And then find a new value of u, my initial velocity. How does that value of u compare with the 28? So how would this u change if I include air resistance? Don't fall into the trap of just saying, well, u would be less because, air resistance would slow you down. It's going to decrease your velocity. If it was asking about your final velocity, or your final distance traveled, yeah, those are both going to be less if you add in air resistance to your model. But the question is asking, same situation, I'm still falling 100 meters away. How fast do I need to throw it initially? So if you're adding in air resistance and everything's going to move a little bit, slower, everything will be slowed down, you're going to actually initially need to throw it a little bit faster in order to ensure it still travels at 100 meters. So because the question is asking for this initial velocity to make it 100 meters, actually it's going to be bigger than 28. So u would be greater than 28. U would be greater than 28 per second. Okay, to make sure it still travels the same 100 meters, even with air resistance added in. And part D, I think part D was about the model, right? Yeah, state one further refinement to the model. That would make it more realistic. Okay. So two things. First of all, don't write air resistance. Please don't. I've seen that so many times. Part C says we include air resistance, and then part D says state one further refinement. So if you write air resistance, you'll get 0 marks, okay? It wants something else, something extra other than air resistance, which is, the most obvious one. That's what everyone always writes. These questions are always pretty nice, because it says refinement to the model. That makes the model more realistic. 9 times out of 10, at least, right? You can just look for the word model in the question. So where does it talk about the model in the question? Going very carefully. In this 5th line here, the motion of the ball is modelled, so look for the word model. Whenever it asks about refinement to the model, it's modelled as a particle, that's one thing, and it's moving freely under gravity. That kind of gives us another clue. Usually the best answer for this one is just talk about modelling at the particle. That's a very safe bet. That's always going to be there in the mark scheme, unless it's explicitly saying it's already said that one, give it a different one. Modelling the ball as a particle, it's always in there. It's a good choice. That's what I'm going to write. So because the ball is modelled as a particle, I'm going to say, to make a more realistic model, I'm going to say, do not model the ball as a particle. That's the easiest answer. You look for the model and you see what you would change. In a pulleys question, it will say that the pulley is modelled as light and smooth, the string is modelled as light and inextensible. Any of those you could say, don't model the pulley as smooth or the string as light or anything like that. Other acceptable answers for this one. So modelling the ball as a particle, you could phrase this in a way. You could say sort of, include the size of the ball or the shape of the ball. Because it's a particle, it's now 3-dimensional. It's got size, it's got spin. So you could say include the effects of spin. You could say that. When it says moving under gravity, you could talk about use a more accurate value of g. 9.8 is not exact. Use a more accurate value of G. Another silly answer they actually do allow, they wouldn't allow air resistance, they would allow wind. I would never put that one. Right, it literally says model as a particle in the question. Go with that one. The things you're not be allowed to say include the mass of the particle. I mean, for one thing, because it doesn't say the ball is modelled as light. I guess it says model as a particle, which doesn't really. No, yeah, it doesn't say it's modelled as light. And also the mass doesn't affect it anyway. In these equations, the acceleration is g regardless of the mass of the ball. So mass is definitely not an answer. Another answer which is not accepted would be don't model the ground as perfectly horizontal or the cliff as perfectly vertical. And the reason why is because it does not say that is part of the model. It doesn't say model the ground as horizontal. It just says the ground is horizontal. So it's saying refine the model. It's saying refine the bits you've actually modelled. So that's why you have to just look for that word. And you should never lose a mark on here. It's, look for the model. It's quite a lot of time, this particle sentence will get you the mark. So I hope that's helpful. We could try looking at a more complicated kinematics question next time. This is a very standard one, but these are the basics. So let me know any questions or anything, or any requests, and I'll take a look.